like that was a special way to ask a question. Okay. Okay? Here's number 2. Oh, why? What? Why did it just like skip to the very front page? My computer's been doing some really wacky stuff lately. I don't know why. Day 11, let's try that again. There's day 12, and there's number 2. Okay, so I got y of 3, 1 over root 2, or root 2 over 2. And then I just used math 8 on my calculator. Y'all remember math 8? Remember math 8? It is exciting.
But I did it before you calculator acted.
I'm sorry. Yeah, I just kind of thought about that after the fact.
I found it negative. That was negative.
And yeah, well, however you get there is fine. I was just kind of in the investing. It'd save you a few minutes maybe to do math 8. So the calculator's active. Math 8 would be a thing. So then I drew a little picture. I drew a picture with the particle being at roughly y equals 1 over root 2. For me, it just basically was above the x-axis. And so because the particle was above the x-axis and the velocity was negative, velocity negative means it was moving down towards the negatives. Since it was above the origin and moving down, I said it was moving towards the origin. Number 2, kind of a harder question to think about, right? Using position and velocity together. The answer is part of it moving toward the origin. Again, maybe a question or something to clarify? Yeah.
I don't understand why that means it's moving towards the origin.
So my picture is a pretty good representation. So if I just told you, let's put it like this. If I told you that my velocity was west, if I just said, I'm moving west, and I said, am I moving towards, oh gosh, this is two-dimensional, so this could get kind of messed up. If I told you I'm moving west, I'll put it like this. If I said, I'm moving west on I-70, I'm moving west on I-70, am I going towards Denver or away from Denver? I'm going west. You all know I-70 is an east-west freeway, right? I'm going west. Am I moving towards Denver or am I moving away from Denver?
Away. Depends on where you are.
Doesn't it kind of depend on where I'm currently located?
Yeah.
If I'm in Kansas and going west on I-70, well, I'm going towards Denver. But if I'm in Utah going west, I am not moving towards Denver. I'm moving away from Denver. Does that make sense?
Yeah.
And so, in order for me to decide if am I moving towards something or away from something, I've got to know two things. I've got to know where am I located right now, and what is the sign of my velocity. If I know those two things, I can like draw myself a little map like I did, and determine, okay, I'm moving away or I'm moving towards. But you got to know where you are and the direction you're moving. I know both. Good question. Anything else? Okay, so here's number 3. Number 3 was pretty loaded. There was a lot to think about there. So I got 2 different intervals where G is concave down because I found that that's where G double prime was negative. And then I got 2 points of inflection at negative 1 and 4. That's where G double prime changed signs from either negative to positive to negative.
Do you care about brackets or parentheses?
It just has to concave down.
Yeah, so like mine look an awful lot like parentheses.
Yeah.
If I was going to be all rigorous about this, I probably would have put brackets. But that's going to not be something that I'm going to take points off for and say it should have been a bracket. Like if you have a bracket infinity, I'm probably going to be pretty offended. But otherwise, I think we're right.
Would you really be offended by that?
Yes, because that tells me that you know how to count to infinity and I don't. And I feel like I want to be able to count to infinity too.
4, 5,
and I'm upset.
We beat my name is
Okay, so 1 and 3, some really good, just very recent reviews. Number 2, a little bit older, but very applicable when you're considering stuff you'd have to be good at for Monday. Any other clarifying questions or just wrap up? Any concerns? All right. So today is going to be a very calculator day. So if you would, get your calculators out. We're going to use these to our advantage. So have those out and at the ready.
You kidding me? You want me to use it instead? You did.
Okay, so today, hey, listen up. Today's going to be about decomposing grass and a water tank. So if that sounds like applications, it is. In fact, this is a really nice segue into what we're going to be doing in Unit 4. Unit 4 is 100% applications, and this little bit of applications at the end is kind of a good transition between what we've been doing and what we're about to do. So please take a minute and read this over. If anybody's ever mowed grass and had to dispose of grass clippings, you know this to be true. It says grass clippings are placed in a bin where they start to stink and decompose, right? So for the time interval from 0 to 30, the amount of grass clippings remaining in the bin is modeled by AFT, where AFT is measured in pounds and T is measured in days. Find the value of A prime of 15, and that's where I want you guys to start. Please remember that the calculator is active. I put that there at the top. Well, please find an opportunity to use your calculator. And once you've found A prime of 15, if you can, use correct units and interpret or describe the meaning of that value in the context of the grass. And you think you can do that, try to write it down. See if you can do it. So first task, though, is to find the value of A prime of 15. Sorry? Oh, okay.
Would it matter what mode you're in?
Say one more time.
It wouldn't matter what mode, right?
It wouldn't, yeah, because there's no sines or cosines or anything in there. So you could do either one.
Is yours dead? Oh, is it the same one as? Yeah, it's how many of these percentages per day. Like what, how much? Let's see.
Okay, so did you guys all use Math 8 to do this?
Yeah.
It's possible to do it without Math 8, but I think, I want to say this, and I'm going to say this, I think with 100% confidence. If the calculator is active and you're supposed to be finding a numerical value of a derivative, you'd better use Math 8. You might not even have the skills to find the derivative on paper and pencil, or it might just take forever. If the calculator's active and you're supposed to find something like this, use Math 8, begging you. Please do. Okay, so if you did, let's hear what you got. I definitely don't have the answer to this memorized. So what'd you get, A prime of 15? Negative 0.1, say it again?
Negative 0.164.
164. Do you guys agree with that value? Did you notice that he expressed his answer to the third decimal point? Or third decimal place to the right of the 0? That's exactly what we want to do, right? We don't want 1 decimal to the right of 0. We don't want 2. We want 3 or more. So we're good, right? Got 3 or more. We're all good with that number? Okay. Did anybody take the next step and take a shot at the explaining what that means? Hunter did. Anybody else? Luke did. Carson did. That's it? Okay, so I've got maybe like half dozen of you at the most that did. Will the rest of you try? Please. And if you need to peek at Luke's paper or Carson's paper to get a sense of what they wrote, do it. But I want you to try, and then we'll hear their thoughts, and then we'll try to get a good answer up there. Sir. Oh yeah, Matthew, you got the TI 83,
Yeah.
so the syntax is a little bit different. So what you got to do is you enter the function first, 6.687 times 0.931 to the t. Got to go comma x. You're going to basically telling it to do ddx, like that's what that means.
Okay.
Comma 15.
Okay.
You're saying do the derivative with respect to x of that thing, and then plug in a 15.
Okay. Okay, thank you.
So I will say, if you say you're doing your homework or something, you're studying later on, and you forget how to do that, just get on YouTube or Google like TI-83 Math 8.
Okay.
Guarantee some video will show up.
Okay, thank you.
I probably have one in my library somewhere, like way back from whenever, but that's how you do it. Okay. Anybody else? Anybody figure some stuff out about interpreting what this means? Carson, I'd like to hear what you wrote down, had to say about this.
This means that it lost 0.16 pounds on day 15.
This means that it lost 0.164 pounds on day 15.
Yeah.
Okay. Agree, disagree, sort of disagree, all the way disagree, 100% agree. Where are you at? You disagree. Okay, let's hear what you have to say, Maddie. Let me change colors here. Go ahead.
I could be wrong, but I think it's the rate of decomposition at 15 days.
This is the rate.
The average rate of change.
Oh, the average. Okay, so hang on. This is the average rate of decomposition.
Yes.
Decomposition. How did you finish again?
At 15 days.
At 15 days. Okay. Kind of different, right? The red and the blue are definitely saying different things. Luke, what do you have to say?
You take out the word average.
So this
Instantaneous.
is the instantaneous rate of decomposition at 15 days. Is that what you're going for? Okay, cool. So we got 3 of them, and they all say something different. Does anybody have a 4th one that says yet something else different? Yeah, Caitlin.
I said pounds of grass clippings per day that are in the bin at the time of 15 days.
Okay, pounds of grass clippings in the bin at t equals 15 days?
Per day.
Oh,
At t equals 2.
pounds per day?
Yeah.
Okay, pounds per day of grass clippings in the bin when t equals 15 days? I just want to make sure that I'm accurately writing down what you're saying. Am I doing that?
You actually wrote it down. It wasn't accurate though.
Wait, did I represent you?
You represented what I was saying.
But now you would wish you could change it.
Yeah.
Change it. What do you want it to say?
Okay, I want to say what they're saying, but I don't think it's like the decomposition because it's talking about like the amount in the bin, but like you couldn't have a negative decomposition.
Oh, okay.
Something.
Okay. Anybody else? Well, we'll try to clear that up in a second. Hunter, what do you have?
I think this is the rate that the grass clippings are taken out of the bin.
The rate at which the clippings are taken out of the bin. Was there anything else you wanted to add to that? It sounded like you were going to say something else, but no? Yes?
On day 15.
On day 15, okay. Okay, I'm kind of out of room. It's kind of pretty up there, nice, lots of nice colors. So there are some up there that are very close. Some that are less close. I'm going to highlight the one that I would say is... I'm going to highlight the two that are probably the closest. So this one's pretty close. This one's pretty close. Neither of which are totally right. Let's talk about this. Let's establish this for sure. This is an important one. AFT stands for the amount of grass clippings, right? AFT stands for the amount of grass clippings still in the bin. So wouldn't A prime be the rate of change of the amount? That makes sense? So I don't think we can say the first one, because that's just saying that it lost a certain amount. And if A is an amount, A prime has to be a rate. Does that make sense? Okay. So it's not that. I think you know this already. What's the issue with the red one?
The average.
Average. It's not an average rate of change. Why is it not an average rate of change? We used a derivative, didn't we? We used a rate of change at a particular point, which makes it more of an instantaneous rather than average. If you take away the word average, well then I would say you're in the realm of the other two highlighted ones, for sure. So you're fairly close there. The purple one, I've been pondering, pounds per day of grass clippings. It's kind of like when I screw up the units on that one, it's kind of like it's this mix of things, right? So I'm looking in the mirror when I say this, so don't take this the wrong way, because I somehow wrote the wrong units down on your review question, but it says pounds per day of grass clippings in the bin. It almost is like it's a rate and an amount, kind of. It's a little confusing. So that's why I would say that I would not go with the purple one. But I would say that the two highlighted in yellow are still, they're not there. So can I give you what would be my ideal answer? And I'm so hoping that there's somebody in this room that basically wrote this down and they were just being shy and very humble, and they're like, I probably got it wrong. But you actually got it right. So maybe it was you. Yes. So here we go. Now, I'm going to write something up here that I think is good. You would not have to just like parrot this back to me. There could certainly be some variety here. I would say this. Because A prime of 15 is negative, the amount of grass clippings is decreasing at a rate of, I'm going to leave this part blank, and then the units would be pounds per day. So we're going to fill in the blank here in a second. So guys, A prime of 15 is negative. The amount of grass clippings is decreasing at a rate of blank pounds per day. Anybody want to venture a guess what goes in the blank? Jed, what do you think? Whoa, you were on it, dude. That's awesome. Why on earth would you put positive? Because we all saw the number up there at the top was negative. Why would you put positive?
Because this is decreasing.
Decreasing, there you go. So this was kind of the issue with the two that I highlighted in yellow. They were both kind of a double negative because it just said this is the rate at which something's decomposing. Well, if something's decomposing, that implies that the amount is decreasing, but if it's decreasing at a negative rate, what does that mean? It's actually increasing, right? And so we want to be super careful that we don't throw double negatives into any explanations like this. And so Jed's idea of putting that particular number in the way that I've explained it fits perfectly. It's exactly what you should put. Okay. Anybody looking at this in the gray box and thinking, oh, Lord, help me. If I ever have to do that on a quiz or a test, it's going to be a struggle. Yeah, you're going to have to do that. You're going to. So when it comes to applications in this class, like I think we are missing the mark completely if all you can do is say, oh, I did some calculations and I got a number, but I have no idea what it means. I think we've missed the mark. I want you to be able to tell me, I got this number and it's negative and here's what it means. The grass clippings are blah, 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 and here would be the units that go with it, so on and so forth. Now, the one thing I didn't put here yet that you all put, and you were right, I need to put on day 15 as part of my answer. And you all put that, so that was correct and needs to be there. But the part we needed to clear up is that it means that the amount of grass clippings is decreasing with correct units, pounds per day, so on and so forth. So the thing in the gray box, that would be an example of an ideal answer. Okay? That's what I'd want you to shoot for. Okay, how are we doing? It was easy to find the derivative, right? Hard to explain. All right, so we are going to wrap up here. I really like question number 3, but as is typical, we rarely have enough time to just mow through them all. Number 2, though, is a must-do. Okay, so the reason why number 2 is so much of a must-do is because number 2 is going to kind of introduce a whole new classification of questions. So from here on out, we're going to do all kinds of different questions in a variety of different looks and ways and the way that they're formatted. But from here on out, you're probably going to call questions like this the water tank question. Okay? So here we go. I'll read this out loud to you. And this is calculator active, by the way. So it says the amount of water in a storage tank in gallons, so this is an amount, is modeled by a continuous function. We never really learn what that continuous function is. Man, I hope you pay attention. This is a complicated question. That's why we're going to kind of do this together. T is measured in hours on the interval 0 to 7. In this model, rates are given as follows. The rate at which water enters the tank is described by F of T. But the rate at which water leaves the tank is described by G of T, and it's piecewise. They're both measured in gallons per hour. So basically what we have here is we have a water tank, and there's water flowing into it, and there's water flowing out of it. Is there a leak in the tank? Maybe. Is there a valve down at the bottom that's releasing water? Maybe. All we know is that there's some water entering the tank at a certain rate, and there's water leaving the tank at a certain rate. Up here at the top, I put this phrase, net rate. It means that there's one rate making the amount of water increase, and there's another rate that's making the amount of water decrease. So there's a net rate, or sometimes people will call these competing rates, because one rate's trying to make the tank get full, and the other one's trying to empty the tank, right? They're competing. A net rate would be a good thing to call this. Okay, so we got a lot of complicated stuff going on here. And the question says, for that time interval 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Justify your answer, and I've given you a lovely graph over there. Help signify this. And let's label it. What do you think the curvy graph is? The curvy graph is definitely F of T. Does that make sense then that the horizontal lines would be G of T? That go with the piecewise graph? Yeah. So G of T is here and also up there. Okay. So let's think this through together. Guys, this is a complicated question. There's going to be tempted to do some wrong stuff, and I want to try to help you with that. It says, find the time intervals during which the amount of water in the tank is decreasing. So if I said the amount of water is decreasing on such and such an interval because, what would be my justification? The amount of water is decreasing because? Say again?
There's a leak.
But use calculus. Come on. Something, okay, let's back it off. Something is decreasing because?
Negative derivative.
Say again?
Negative derivative.
Yeah, or could you say something is decreasing because something prime is negative? So if I said the amount of water is decreasing because, no, just think really general. That's actually a mistake. The amount of water is decreasing because, how about this? Amount prime is negative. The amount of water is decreasing because amount prime, whatever that is negative. So we'd be looking for where the rate of change of water is negative. This is where this gets tricky, and this is where Hunter just stepped right in it a second ago. He said, because f prime, blah, blah, blah. Can anybody tell me what kind of thing f of t is? F of t is already a rate of change of the water. So if I were to find f prime, wouldn't that be the rate of change of the rate of change of water? It's going too far. So the real trick about a question like this is this. Here's the crux of it. You're going to have to use derivatives to answer this question, but the fact of the matter is, they already gave you the derivatives. And you need to know that you don't need to differentiate them to get the rates of change. Do you get it? Somebody who really knows what they're doing would look at this and say, oh my gosh, you already gave me the rates of change of water. I don't actually have to do any derivatives here because you already gave me the derivatives. Somebody who doesn't really know what they're doing, they're going to say, well, gosh, this is a calculus class, and I have to find derivatives, and so I'm just going to differentiate whatever you put in front of me. Right? That would be the uninitiated person approaching this. The person that understands would say, whoa, you already gave me the rates of change, so I don't need to do a derivative. Are you following me? So check this out. Here's what we would do. If I'm trying to figure out where the amount of water is decreasing, I want to find out where amount prime is negative. So wouldn't it be useful to find out where amount prime is 0? So check this out. I got to do this in two pieces. I would say f of t minus 250 equals 0. Or f of t minus 2000 equals 0. Oops. So please notice all I've done is I've taken the rate of water coming in minus the rate of water going out. Why would I do it in that order? Why would I subtract?
Because when you subtract that, you find what it's.
Find what?
Find, because f of t is increasing.
Yes.
GFT is decreasing.
GFT is causing it to decrease.
And they're at 0, and you subtract them.
Yeah. Yeah, because the rate of decrease is presented as a positive number, right? It's 250 or 2,000. So I need, because that's causing the amount to decrease, I need to subtract it. Okay, so then I need to use my calculator to figure this out. So if you would, take a second, use your calculator. Let's figure out what t equals. So you could, you can use the zero finder or the intersection finder, right? Is it yes? No? Are we good with this? Basically, solve the equations using your graph on your calculator. And you do have to be in radian mode, physics people. You do have to be in radian mode. Please finish what you're doing with the calculator. I'm going to show you your tests. You get your own version. Thanks for asking. Lars, go.
Probably got I missed it. I didn't see it.
So, hey guys, we just have to kind of cram this in, and I do apologize for the distraction. Take 1 second and put your test down. Let's wrap this up. I know for sure that my first t value is like roughly 1.6. What is it exactly? Or at least to 3 decimals. 1.617. Or the other one, bless you, is about 5. Yes? I'm looking at this intersection point right there.
I got 4.5.
It's got to be right around 5. Did anybody get 5 point something? I think that's it. I remember enough that it's 5 point something. Okay, so here's how we would wrap this up. I've basically got 4 intervals, a yellow one, and an orange one, a purple one, and a green one. And the relationship between f of t and g of t is going to change depending on which interval you're in. So in the yellow interval, do you see how g of t is higher? On the yellow interval, g of t is the higher function. So I would say on the interval from 0 to 1.617, I would say that f of t minus g of t is negative, isn't it? Because g of t is the bigger number on that interval. And do you guys see any other intervals where that same pattern is in place? Purple, right? Do you see how on the purple interval the g of t is higher? So we'd say, and on 3 to 5.076, same thing. And essentially, aren't we saying that the rate leaving is greater than the rate coming in? That's really all we're saying. So we can say, therefore, the amount of water is decreasing on those intervals. What's challenging about this one, of course, is that you've got 2 different rates acting against each other, so you've got to consider both. You can't just consider one. Okay. Man, I really, honestly love number 3. I might find a way to work that in on Monday or something.